Before I talk any more about any other Taylor series, what I want to do is I want to talk about a following corollary. And this is also something that seems obvious, but there's a good reason for it to be true. And so the following corollary is this. So suppose that we have two power series. We have a power series C sub n, z minus z naught to the n, as n goes from 0 to infinity. And suppose we have another power series d sub n, z minus z naught to the n, as n goes from 0 to infinity. And suppose these both converge to f on some disk. So they have some radius of convergence. Inside the radius of convergence, they both converge to f. So I'm not saying that they have to be the same radius of convergence, but just on some disk centered at z naught of radius r. So just to clarify what I just said, this outer power series, this first one I mean, C sub n, has some radius of convergence. Call it capital R1. Okay, capital R1 is this distance really. And then the other power series has maybe some other radius of convergence. No idea what it is. Maybe it's smaller, maybe it's bigger, it doesn't matter. But there's going to be some disk centered at z naught of some radius. So let's call that radius r. So r is going to be the minimum of the two radii of convergence of the original series. And so they're going to have this disk in common. And so if they both converge to this function f, they're going to both converge on this smaller disk. And in particular, what that means is that this forces c sub n to be equal to d sub n for all n. And the reason why is that we just showed that inside the radius of convergence, these sequences, c sub n and d sub n, have particular forms. They're going to be the kth derivatives of our function at z naught divided by k factorial, but they're both equal to that. And therefore, they're both equal to each other. That's basically the proof. I'm not going to write it down. But this is an important corollary. If we have two power series that are equal on some disk, then the coefficients all have to be equal. Okay, so next, let's talk about some further examples of power series.